From the special theory of relativity, we get the speed of light is constant and a universal speed limit, length contraction, time dilation, and mass accumulation. This presentation will focus on mass accumulation. The following presents a paradox when considering mass accumulation. In our paradox, we're going to use the furthest object known to man, GNZ11, Earth, a space station that is equidistant between the two rockets, and 4 astronauts. The Earth and GNZ11 are separating at a rate of 0.971 times the speed of light. They're both separating from the space station at 0.4855 times the speed of light. The rockets are identical in mass and performance. They will rendezvous at the space station to refuel and swap out 2 of the astronauts. Each rocket has receded from their home station and are now at a constant velocity of 0.4855 c relative to home. Since the GNZ11 rocket changed directions, any acceleration toward GNZ11 will result in a reduction in the relative velocity between it and home. The Earth rocket will, however, continue away from Earth, increasing its relative velocity away from Earth. Notice that the Earth rocket is not keeping up with the GNZ11 rocket due to its increasing relativistic mass relative to Earth. As the red rocket's velocity becomes equal to that of GNZ11's, or 0.971 c relative to Earth, they realize they have a serious problem. Since the red rocket took on an Earth passenger, she now has a relativistic mass of 4.18 times her mass on Earth due to her velocity relative to Earth. If they continue accelerating by just another 0.028 c, her mass will become 22 times normal. Another 0.001 increase in velocity, her mass becomes infinite. The rocket is stuck at a velocity between 0.028 c and 0.029 c relative to GNZ11. Notice that the blue rocket still has its engine running, however, it's not catching the red rocket. The blue rocket's entire mass has increased due to its velocity relative to Earth. What mechanism keeps track of what mass came from where? Even if the red rocket took a single feather from Earth, their acceleration would be halted prior to reaching 0.029 c. Can we switch inertial reference frames? Can the blue rocket say its relativistic mass is now relative to GNZ11 instead of Earth? Who would know if they did?